Let's kick off the afternoon with our next speaker, Nicholas Dijkhoffz of NASA Johnson, and he'll be discussing multiple target hardware system manager for flight software CI/CD. Take it away, Nicholas.
Thank you. Mic check. Everyone can hear me? I'm pretty loud. Okay, thanks, team. I got my team back there. So I hope everyone had a good lunch. It was a good tour. Went a little bit long, but it was pretty interesting. I think it was a curveball they threw me there. But yeah, like I said, my name is Nicholas Dijkhoffz. I'll be presenting a topic that we've been working on in our Gateway project. I'll go into some more details of specifically what we do, but it's basically some CI/CD and working with different flight computers and applications that are running with them and how we can test that in an automated fashion. So with that, let's get started. A little bit about myself. My background's in EE. I am a flight software engineer for NASA at JSC, part of the Gateway program. I'm working there as a contractor for Medics, which you guys saw a presentation for them on Monday. I've been working with embedded systems almost 8 years, and it's kind of how I kind of just arrived to that. But it really has been something that I've been happy to work on ever since I graduated. So. I just get to now say I do it with stuff that goes to space. So that's pretty cool. So before I kind of started this whole thing, I wanted to give a little story about why I think this is important. Why, I think everybody's kind of aware of the need to kind of do this on hardware, but I wanted to use this story that I kind of went through back when I started. I worked for a water meter utility company. They made these devices that converted this mechanical to an electrical read. They'd have a radio connected to it and try to read it every certain amount of time. I think back then it was every 15 minutes. And we were going through a new product development cycle. And this product was, it was supposed to be the next big thing, great. And we started doing our environmental testing, which is we put them out in a field that we used to call the farm, and these were underground. And we would just leave them there for months, trying to see how it would react and if there's any issues and that sort of thing. What we found was that after about 10,000 cycles going, we start seeing these read failures that were very spontaneous, and they weren't consistent. They would fail once, and they had this issue which they had trained our customer to see that if there was a failure, it was catastrophic and you needed to call them immediately because they had to go replace the meter, and that had been perpetuated over time. So of course, when we saw that, we had to go in and check and see what was going on. We wanted to go and reproduce it. It was very hard to reproduce because it was only after a certain amount of cycles that we kind of were able to do that. So we had to, I was working at the time with a device that was able to mimic the communication of the radio with the register. And we were able to modify that to be able to just cycle through a lot quicker. So instead of waiting every 15 minutes to read, we'd query every 5 seconds. We set that up in a lab. We hooked up a scope, not that scope, that's a really old scope. But we put a scope that's sniffing the lines, and one of our test engineers set up a little LabVIEW application that would actually capture the reads on the scope, so we could actually see what was happening. Was it an actual error from the register that it wasn't producing the read? Was it actually the radio device that was not taking that information and transmitting it? We didn't know. So to continue and finalize the story, we found out that it was a race condition. At the time of the read, an interrupt was being hit, and it was just jumping up to another part in the code, and it was causing it to fail at that point. And it took us quite a setup to do that. Now, the reason I bring it up is because we weren't doing that frequency of testing on hardware. And that sort of thing would have, it would have captured that. And in fact, they continued to do that moving forward for their new product development. This just became part of their, of their testing that they would do besides, having a tester go through some test plan. So that's kind of like what I want to start off with and highlight. So what's my goal for this presentation and for this work that we're doing? I wanted to present to you guys what we've done in this project, of how we're testing with these different flight computers and how we're trying to automate that process. It's about being more effective and continuously being able to test the software actually running on hardware throughout our development cycle. We see that that happens later on in processes or in the project, but we want to start that a little bit earlier because it helps us, detect things that you could only see when the software is running on the hardware. We want to talk a little bit about some pitfalls and maybe issues that we can run into, some potential options for improvements, what are some of the paths forward, and also, just request that, the community be engaged a little bit so that maybe we can come up with a much more generic version of this. So to talk a little bit more in depth about this specific problem, we were running into this issue in a previous project where we just happened to see some issues when running on hardware that were probably not documented correctly, and they caused a little bit of confusion. This software is much more complex, and there's much more room for things to go wrong when they're running on the hardware. So we thought that we needed to be able to test this more frequently in a way that we're not waiting till the end or some checkpoint and we're starting to find some issues there. Now, it's easy to say that when there's certain conditions within the project, but for this case, we have some limitations. As for example, the hardware is really costly, right? And there's a limited number of resources that we have available. We have a very big development team. I think I was counting maybe like 40, 45, but I think our number is closer to like 60. And everyone's in need of these units, and they need them for their testing. So it's a location for a bottleneck to happen. People are then waiting to perform their test. It's all very manual, and then that could cause maybe some issues, some schedule delays of delivery for the sprint or from some other marker that we have to deliver. So it's a place where we really could benefit from trying to streamline the process a little bit more. Now, I wanted to give some context to the project. It's the Gateway program, which is a lunar space station. There's a couple of modules. I don't want to go too into it because I feel like this could be a presentation in itself just for Flight Software Workshop, maybe something for next year. But we're working, the module that my team is working on is the power and propulsion element. And I think another component that's being launched, they're being launched at the same time with, is the HALO, which is the Habitation and Logistic Outpost. There's two applications of CFS that I'm concerned about, and I'll show that in the next slide, but one of them is called Vehicle Systems Manager, and the other one's the one we're developing, which is the Module System Manager. They're basically just interfacing with each other, communicating telemetry and commands and handling. So I put a link there in the slide if you wanted to go to the NASA website and get more information about the program as a whole. You can see the multiple partners there and the other modules that will come at a later time. Here's a high-level diagram of what we're trying to test. Like I mentioned, we have the VSM and the MSM. These two applications, they're two flight software or CFS running on separate flight computers. And then at the bottom right, we have what I call a simulation source. It's basically providing telemetry data that we are expecting to see at the MSM level. And if we also have to send it commands, it could kind of process it for us, make it very flight-like. So that's what we're trying to achieve, is try to get as close to how we would fly as possible. And then I wanted to talk a little bit about our development environment or some of the tools that we're using. We're obviously using core flight software. We're using the test framework from CFS to write our scripts for testing. Python and Shell, we use that for functional tests and automation of some of the testing that we're doing. We're running our static analysis, which we're using Understand and CPP Check. And we have some, project management tools and documentation that, it kind of links together because we could automate it in part of the process of building stuff. So just wanted to make a mention of that. Now, a little bit about how we're testing. We're obviously doing unit testing. This isn't something far-fetched. Pretty much everybody's been doing that. Functional testing as well. Some of this tests we run on Linux. We're not running it on the hardware, so it's going in our pipeline. We're still running the static analysis for our coding standards. And then comes the actual target testing. Now, in this case, we're running some of our scripts on target, and sometimes that's just interfacing with our flight computer and the MSM that we're developing for, but sometimes we want a more integrated level test where we want, the other VSM application and have it interface with that's then communicating with the MSM and get the response, see if we're making, certain use cases and meeting those requirements. I put GitLab there at the end because we are running the unit test, functional test, and understand all in GitLab pipeline. We get our results there, but the hardware testing part, we were not able to do with GitLab, which I'll explain what we did next. A little bit of our hardware setup. We have our flight computers in test racks in our lab. That's managed by our IT team, but we support them with configurations of the flight computer and sometimes the network connections. Our developers have to SSH into the racks. They SSH into the local computer that's connected to them, and then they're able to load and build with the right licenses, the binaries that then need to be tested. I think we have 5 racks right now, and they have similar configurations. Our goal really is that they all kind of match so that there's no issue with different developers wanting a certain rig over another, and that way we can kind of maximize the use of all of our resources. And currently, as I was saying, in what we're doing in CI/CD right now, or what we were doing before, we got our GitLab pipelines as part of our merge process. We go through all of that, make sure all of our results are passing, all of our tests are passing. And then we do our hardware testing, which is, we build and run the CFS application on target and run all of our functional tests on target manually. It's kind of this iterative approach as agile that we're trying to do. So what we would want to do, and what some of them I'm going to talk about next, is kind of like scheduled hardware testing. We want to be able to, we don't have the automated hardware part yet for scheduled testing, but that would be the goal, is some level of regression testing that we can do maybe on a nightly basis build or a weekly build, and that way we're capturing a lot of our previous tests to make sure that we're always consistently not breaking the code base when we're merging new stuff. All right. Which comes to the automation of that hardware testing. We tried looking at different things that we could do. We had Jenkins available, so we kind of went that route. We have runners on our lab machines that are connected to the test racks. And the steps are pretty basic. We clone the latest development branch. We build that application. We're able to script and load the binaries onto the flight computer and run batches of CTF. For now, we're going pretty simple testing. And then, we're able to capture those results and post them somewhere for anybody to be able to look at, see if they need to check if there's any failures. It's open also for other people outside of the team to be able to look at as well. The goal, one thing that I wanted to mention here is we really wanted to make a one-click and done solution. So basically, developers should be able to go and just say, I'm done, I want to run this, and just click a button and just let it run, and you'll come back in a certain amount of time, and you should have all of the results for your testing on target available for you to check. So, and that's what we've achieved. The next step, besides running it on our target on our flight computer for the MSM, is integrating the VSM side, or the second flight computer. This is a little bit trickier because we do have to set that part up correctly, but it's not something that is usually done, and we want to do it more frequently. That's a diagram kind of similar. I put FC1, Flight Computer 1, and Flight Computer 2 to kind of showcase a little bit of the diagram, so it's really high level there. But and then comes the topic of the Target Hardware Resource Manager, which I'll talk about what the biggest issue there is. So right now, we have this large team that's sharing these resources, and there's no good way to communicate with each other except just have to talk to somebody. And sometimes we have people taking up resources, and we have to go check with them and see if those resources are now available for all the tests. And this is where our path is kind of taken, as can we have some sort of supervisory application that's monitoring the status of all the racks, checking the flight computers that are available, so that we, instead of having to coordinate that effort with all of the developers or anybody who's working on it, it's a much more streamlined, automated operation, and you're actually just clicking your button, and take that application will just verify what flight computers are available and run wherever they need to run. We're trying to do that to, like I said, streamline, but also kind of reduce the amount of time developers are spending in the actual process of running the test. Our test bank is kind of low right now because we're doing very simple stuff, but we've reduced that down to about 5 minutes. And with all the configuration, it could have gone anywhere between 30 and 40 minutes before. So we have some current options that we're looking to do that. We have an in-house framework that could provide us the capabilities. It doesn't have it off shelf, but there's a limitation that it could take a very large amount of time in development. We're not DevOps. We're not a team of DevOps people. We're the flight software guys, and we're trying to just figure out a clever and effective way to test on hardware frequently. So, and I'll talk about that in the next slide, about what are some of those issues. The other way we've been kind of looking at it is just trying to do some scripting from the command line on the flight computers to kind of detect, what the memory usage is, if there's any processes running on it, and that way have some sort of, some control of what flight computers would become available for us to use. It'd be very cool to have something that is open source that can do that, and I'll bring that up here. This is another diagram where I kind of have that block of that target resource manager application that's looking at all the racks. Now, there's potential issues with that, and the network configuration of all the different flight computers that are involved. I mean, there's heavy maintenance going on that all the time down in the lab. There's things that are changing. We have the issue that if we continue to have developers being able to use manually the computers, how does that interface with this supervisory application? Does it know that a developer took that? We haven't figured out a way of what way can we prioritize the use of resources, and if it takes one and then somebody takes it away, how do you handle that situation? It's one of the difficulties that we're running into. There's also potential changes in target hardware. Sometimes sometimes you need to swap up a flight computer, and we don't have another version of that, so we have to get with another development board, and that requires some changes. And then there's the maintenance of that application. Now, on top of the fact that you're writing flight software, you also have to maintain this other application. And if there's, like I said, we're not the DevOps people, so it's a potential issue for some headache down the road. I'm doing on time, good. But yeah, the closing thoughts for this is I really don't think there's a perfect solution. I think we've been looking for something off the shelf that could help us really kind of manage the resources and kind of help with the flexibility of having all developers just be able to streamline the process. I think there could be something out there. We just haven't found it yet. The in-house solution is still a possibility. It's just, if it's something that would be worthwhile being able to do from a small, project and scale up to a much more complex, larger project. So, and it needs to be cost effective, because, it happens so much in projects where you're trying to you're trying to set up these processes so that we can test, but how much time are you actually going to spend writing and putting up the test setup? It's usually a fine line of how much you want to do. There's discussions for packages that could probably assist and maybe become something a lot more generic. We're really open to that, and something that can easily integrate into our CI/CD tools. And that's pretty much all I got. I just wanted to shout out appreciation to NASA, JSC, our leads, David Swartout and Scott Cox, our Gateway development team, who's also involved in this. And then our MSM team and medics team, a lot of the guys that are working really hard on trying to figure out a solution for this are actually here. Max Smith, Zach Mexinger, they're both here. Travis Christian was another individual who put a lot of work into this, and I got some contact information, because I'm really open to discussing this with anybody who's running into this problem and are probably looking at a similar solution. And with that, I wanted to open up to questions. I think I did good on time.
Can you hear me? Cool. What made you choose Jenkins over like GitHub Actions, and is your code currently in GitHub so that it's kind of a tighter loop for CI/CD of any code changes?
We chose Jenkins, I believe, because other people were already using it. and they told us that would be simpler to do. It has to do with also, I guess, you know, what's available to be used within our labs. You know, there's certain restrictions sometimes. So if we wanted to go through another product, I'm sure we could, but we'd have to go through a different process to get it approved. So.
So with the Artemis and Gateway being a collection of subs working to make this integrated thing, most of your presentation looked like it was talking about the NASA side of things, how you get the NASA side flowing.
Mm-hmm.
Have you started looking at how you integrate all these subs, especially the commercial partners and their proprietary software, and get that into this kind of integration loop to make it efficient?
Yeah, and I probably should have been more specific. The reason I'm talking only about that part is because this is our development side. There's a whole other group and other stages in this part of this big, large team that we have that are involved. We have a verification lab that they're the ones involved with setting up the testing, and they handle it a little bit differently. But that's why we're kind of focusing on the two kind of direct interfaces that we have, and those are the ones that we want to, you know, do this integrated level of testing on a frequent basis, so we're making sure that we're not, you know, breaking anything, and we want to do that frequently on target. You know, we can do it in Linux, right, and we can get a good idea of what's working, but it's nothing until you actually test it on the hardware and you start seeing the limitations or the constraints of the hardware. So.
All right, let me take a question from online. Hardware engineering development units are not always available to the CI/CD flight software in the early stages of development. Do you have any comments on that?
You said hardware development units are not readily available?
Yeah.
Yeah, it's a big issue. I think at that point you just do what you can, and you can start your testing with what you know, in this case we could do Linux testing, but I'd advocate to try to get that set up as soon as possible. You know, I've just seen that if you wait too long, and sometimes it's you know, it's not our developers' fault, right? It's just things that happen. So, but yeah, I'd advocate to kind of start as soon as possible. If everybody could have a $5,000 flight computer on their desk, that'd be awesome. Everyone could just start testing every day on their code that they're doing. But it's, you know, it's not a Raspberry Pi, so.
Isaiah Garrett. So my question is, one struggle that we've had on Dragonfly is deciding when to run various parts of our CI. For example, we build every commit, but we test nightly. How do you approach this problem, and how have you balanced those trade-offs?
So since we're still in the process of kind of organizing this, I think the approach we've taken is we have a set of tests that we like to run upon each merge, right? We don't do it per commit. I think that would be quite a lot, and then we already have some GitLab bottlenecks happening with the large team that we have. I think we're getting more licenses, but I think on the nightly build, I think what we're trying to do is this large group of tests that take a very long time. We want to try to do them at times where the resources are most available. So nightly, weekends, very specific times. Another option would be if you wanted to have a dedicated, you know, node that's just for this automated testing that nobody else can use. But that's really not maximizing all of your resources if you have more. So, but that's kind of like the first step approaches that we've looked at.
That makes sense. Thank you.
All right, I guess we'll take one online. What specific tool are you using to manage resource sharing?
That's exactly what we're trying to solve. So we haven't found it yet. Nothing off the shelf. If not, it'll have to be an in-house solution that we're looking at. There might be something discussed later in this workshop. I'm not going to disclose yet, so. But that's basically what we want. And I'd be open to discuss with anybody that has attempted to do this. I mean, if we could share, I mean, that would be much better than just trying to make something that just works for us. So.
Hi. I recognize myself in the situation a bit, changing hardware, software and hardware engineers, about the same team size, and we also use Jenkins. Have you tried lockable resources in Jenkins?
No, and we're interested in looking more at what available packages Jenkins can give us to kind of handle that. It's going to be kind of a cooperative effort too, because everybody's already used to manually just going and taking stuff. So we have to figure out a good way. But that's a good approach. We might want to share a little bit more.
Yeah, because then you can have the automatic builds, lock the resource, and then no one can take it. And if someone takes it manually, they also have to lock the resource.
Okay. Yeah,
so that's quite easy. It doesn't solve all problems, but well.
Yeah, no, that's good. Thank you.
Any in-house?
I'll do you and your email.
All right, I'll tip my hand slightly. How much heckling would you like tomorrow morning from the podium?
Say that again?
How much heckling would you like to hear from the podium tomorrow morning?
Not much. I don't know. I don't know what I'm getting into here, so. But
let's just say that you'll like to see my talk.
yeah, I didn't want to disclose that part, but yeah.
Okay, well, that's all the time we have for questions. Let's
All right.
thank our speaker.
Thank you so much.